My name is John Đức Trung. Currently, I am a lecturer at FPT University, Hanoi, Vietnam. So today, I'm going to present about a research paper entitled on the identification of FOSD-based non-zero onset speech dataset. This work was being done together with our peer in University Technology Petronas, Malaysia. So here's our presentation agenda today. First, we will go through the introduction of FOSD dataset, text-to-speech engine, and there's some related works about the TTS. Then we go through the methodology. Next is the results, and followed by the conclusion, and finally is the references. So as you can see, text-to-speech application requires the clean data. So, for example, if you have the text input, it will have to be corresponding to the voice data provided in the dataset. And because the recorded voice, sometimes it has the silence and also the non-silence in the recorded voice. So because of this reason, and because that we need to clean the data before we use, so often people have to trim down the recorded voice so that it can contain only voice, not the silence preceding the voice portion. So this task is very time consuming, and sometimes it requires manual approach. So there are two options that people can think of when using the data which is provided online or which is published online. Because for those data, sometimes the data set was not clean. For example, there are two options. The first one is to exclude the non-zero onset data, and the second one is to identify which one is the non-zero onset data, and from there they can start to detect the onset and remove the silence preceding the voice. So as you can see from this picture, it is a recorded voice. Here you can see from here, and the voice portion you can see, which is has the wave with the magnitude more than the average value, and you can see the onset was detected here. And as you can see, preceding the voice, recorded voice, there's some small portion which is the silence, and usually this portion is unnecessary, and it can be the noise to the TTS system. So the text supposed to be start from here. The voice supposed to be start from here, and this portion should be removed so that the data set to be used in text-to-speech engine can be clean. And in 2018, FPT Corporation released the FOSD, which is FPT Open Speech Dataset, and it has many data, and there are a lot of data that are not clean or are not useful for the TTS engine, especially those containing non-zero onset files. So because of this reason, we need to clean up the dataset before we use, and this is the main purpose of our research paper presented in this conference. So our key contribution to this conference is that we have published the dataset, which is non-zero onset Vietnamese onset speech dataset, which was retrieved based on the FOSD. And you can see the dataset link here. So here is the related works. As you can see, TTS engine has been developed in recent years, especially in a couple of years ago. And the massive development of the TDS engine, such as WaveNet, WaveGlow, Tacotron, ES Tacotron 2, Transformer, and in our country we have a famous one which is FPT.AI engine, which is currently dominating the market in a TTS engine in Vietnam. And they have a lot of customers from bank, from the credit companies. So for TTS engines, the engines can be used for chatbots, voice bot, and also can be used for automatic call centers. And usually the engines are machine learning based. So our in the recent research here, they do not discuss well about the non-zero onset detection or identification of the input dataset yet. So as you can see, this one's the speech, recorded speech, and onset is started from here. So the portion before the onset supposed to be removed, and this portion is not useful for the TTS engine as it contains the magnitude of the signal which is too small compared to the typical signal as in S1 here. And here it comes to our research methodology. For the dataset, we use the FOSD dataset, which is freely available to everyone, and it was released by FPT Corporation in 2008. This dataset contains over 25,000 audio files, and it has the total duration of up to 30 hours. The data contains in the dataset includes the Vietnamese speeches and also the transcript of each recorded speech. And it was public, and it can be found at the reference 16. And here's our research algorithm, the algorithm that we developed in this research. There are four main steps in this algorithm. The first one is that you have to group all the MP3 audio files in the public dataset into a folder. In this case, we put the name FOSD. And in the second step, we merge all the TXT file in the dataset into a transcript or .txt file. Because in this FOSD dataset, it has 3 transcript files, so we have to group all together so that our dataset can be complete. And the transcript is representing the 3 sub-datasets within this FOSD. In the third step, we run the Python algorithm shown in figure 1 over the primary dataset, which is FOSD. And in step 4, we convert all audio files in MP3 folder into the .wav files and save them into a WAV folder. Actually, in this work, the step number 3 is the most important one. And we have the pseudocode for the step 3, which is shown here. For each line in the transcript or .txt file, if the line does not contain the string 0.5 consecutive zeros or 0 dash, this means that the onset is not 0. Because of this, we append the line into the transcript onset.txt. This one is the output transcript that we publish on Mendeley data. And after that, we get the audio file name from the line. This line is actually a text line. And for example, here's the audio file name that we had. So based on this audio file name, we copy the audio file into the MP3, which is the output folder. And here's the detailed algorithm. You can have a look at it. This algorithm we developed in the Windows environment. However, it can be easily extended to Linux environment. And you can see from here, the settings are all here. And this one is the detailed algorithms to get the transcript. and also to detect the non-zero onset. As a result, we published the non-zero onset Vietnamese speech dataset in reference 18. And in this reference, in this published dataset, we have two folders, MP3 and WAV folder. In total, we have 348 files together with one transcript. You can see here, dataset. And the audio file name format is shown in this figure. As you can see, we have the FOSD name. We have the version of the dataset. We have the S, which is the subset number. We have the YYY, which is the file number. So all the files in this dataset, they have the number. And also we have the extension, MP3 for MP3 format and WAV for WAV format. So the transcript line format is shown in this slide. As you can see, we also have the speech dataset, which is retained and it has not changed compared to the original transcript. The set is here, the version number here, and X and Y are similar to the previous one. However, we have additional MP3 here, and we have the vertical section. After that, we have the text. This one is actually the transcript detail. We also have the time start and also the time end. So as you know, when the time start is non-zero, it means the file starts from non-zero. So the onset is non-zero. This is the way that we use to detect which file is starting from non-zero onset. So here's the detail of which parameters that you can see up here. So here is to be noted that the time start and time end can be multiple pairs. So in case the file has multiple voice recorded at multiple durations within the file, it will have multiple pair, time start and also time end. And here's the sample of the transcript line that we had. So as you can see here, the start time is non-zero. As long as the first one is non-zero, means the file is non-zero onset, similar to this one. So as a result, for our published dataset can be used to indicate non-zero onset data. This can be excluded from the TTS or STT engine. STT stands for speech to text engine. And it is useful for the research related to natural language processing, natural language generation, Vietnamese TTS, STT applications. It is also useful for studying Vietnamese language structure, speech timing, onset detection, speech ending detection, and to develop auto speech timing alignment or onset detection tool. And here's our published dataset statistics, as you can see here. This one's the version number 3. In conclusion, we have presented an approach for retrieving non-zero onset Vietnamese speech dataset from the freely available dataset released by FPT Corporation, which is FOSD. In the future, we will consider to develop an onset detection algorithm that can improve the approach that used in this FOSD dataset. So with that, we would like to thank you for your attention. And you can see our references here. Thank you.